Good morning, all. Am I audible? Okay. So, any doubts in previous class sessions? Okay. So, in today's class, we are going to see another one project by using another one new algorithm. So, today we are going to see about an algorithm called KNN. Okay, K nearest neighbor algorithm we are going to see, and the problem which we are going to solve is salary estimation problem. Okay, so salary estimation in the sense we'll be having a data set. Uh, we will be collecting some information. So one by one we will see. So as a first step, as I told, our problem statement is going to be predicting. Okay, predicting whether the job applicant got salary above 50K or not from the previous company. Okay, so we will be collecting some information about that job applicant, and we will decide whether the person has already got a salary above 50,000 or not. Okay, so for that we need to collect some data from the user, right? Here you who is our user? The job applicant is our user. Okay, and what are all the information I'm going to get from that user is, so based on their age, okay, education number, capital gain, how hours per week, to estimate the salary, whether he has gained 50K, more than 50K or less than 50K. Okay, so these are the input, going to be the input. What are the age I'm going to get, education, and then capital gain, hours per week he has worked. So that is going to be my input part, and output is going to be, it is like true or false, or we can say yes or no. Yes, the person has got greater than 50K, or no, the person has not gained greater than 50K. Okay, so again this is a kind of classification only. Okay, and we are taking only two classification. So then third step, we will be loading and summarizing the data set, right? So that is normal procedure only. So I don't need to explain you further. So loading and summarizing the data set is going to be a general step. And fourth step, so this is something, a new step which you are seeing today, mapping data from to text to a binary number. Okay, same thing we have done in the pandas also, converting a categorical data into a numerical data, that we have done, right, using the replace method we have done. Similarly, in our data set, uh, the output values is going to be in the form of like this only. Otherwise I will try to show you the wait, I will show the. So hope my Firefox also, I mean, Ubuntu environment also visible. Here if you see means, in the income section, we are having the data in the form of like this. Okay, we call it as objective data, right? So less than or equal to 50K, okay, or greater than 50K. Like that it is given. So this objective data type, I'm going to convert it into binary data type. Okay, where and all greater than 50K is coming, that I will convert it into 1, and where and all less than 50K, less than or equal to 50K it is coming, I will convert it into 0. Okay, so that is what I'm calling it as map. Here I'm not going to use the replace method. Here I'm using the map method. Similar kind of syntax only. In replace, we use dictionary to replace, right? We will give the old data as key and new data as value. Similarly, in mapping also, we will give, okay, whichever value matches this particular condition, then convert to 0. Not matching means convert to 1. Like that, we will be converting. Okay. Yesterday program in status, they have already given it in the form of zeros and ones. Zero means the customer will not buy, one means customer will buy. But in today, the data set is different, right? Here it is not in zero one format. It is in some uh, what string format or any object type format is there. So directly we cannot use this, right? Output is going to be in zero or one only. So to make it easier, we are converting like that. Okay. Then okay, this is the one more step we are doing. Fourth step as converting. This is also a kind of pre-processing only. Okay. Under pre-processing only this type of conversion, cleaning, those information will come. Still now we haven't seen any cleaning because all the data, there is no any null data given in our data set. Maybe later some data set if you are having any null means we will see how to handle that. Okay. And in the fifth step, we will segregate the data set into X and Y. Okay, all the columns. Totally, we are having how many columns? Five columns we are having. In that first four columns, I will take it for X variable, and the last column, which is income column, I will take it as Y variable. Okay. Hope my mind map and Ubuntu are visible for you, right? When I'm changing the switching. Okay. So this syntax also you know from the previous algorithms. Okay. So sixth step, what splitting the data set to train and testing. Okay, I am using the same syntax everywhere, but I expect you to, I hope you have already experimented on a previous data set by changing the test size, random state you might have changed and worked on it. Okay. Only if you are practicing only you will know able to know okay how it is happening, which is the best percentage. Can anyone able to get more than 80 percentage for previous data? Okay. Then feature scaling. So obviously we need to do feature scaling for this also, right? Do we need to do or not feature scaling? So we need to do. Why? Because we are having different scaling, like we are having age, okay, and education. It is given in like some numbers 9, 10, 16, 15, like that given. Then capital gain, it is given like 0. Okay, mostly it is 0 only. Capital gain, it is given as 0 only. Okay, so we can go with 0 itself, or we can eliminate that column also if we don't need it. And in the last column, what we are having? No, what is the last column name? Hmm. Hours per week. So per week, how many hours that particular person has worked? Okay, generally per day 8 hours a person is working means five working days means 40 hours he might have worked. Six means 48 hours. So maximum 48 hours will be there. But see, some person has worked 76 hours and all. But literally, how it is possible, we don't know. But it is possible, right? Per day, 10 hours production kind of work and all, they will be working for 10 hours also. So maybe that and all they have mentioned. Okay. See, here if you see means one case, this person has worked only 6 hours per day, but his income is more than 50K. Okay, maybe it belongs to different work work role, job role will be different. Okay, maybe that's why he's getting more paid for less number of hours work. Okay, so we need to do feature scaling for this also. Okay, so again, what type of feature scaling I'm going to here also standard scalar method only I will use. Okay, not the normalization. Very rarely only we go for normalization method because we are stringing the values between 0 to 1, right? So that in that case it will be difficult to predict it properly. That's why we are going for the standardization method. Hmm. Mm. Any particular thing we go for normalization is mm, when we are having very less columns. Okay, and it is that normalization is also called as what, the min max method only, right? In case if you want to where we can use this some data set if you are taking, and you want to differentiate how many gender base you want to split. Okay, male how many of them are there, female how many of them are subscribed to a particular thing. Those type of cases only 0 and 1 is going to be there, right? That time we can go, or percentage, you want it in percentage. So if you are converting it from 0 to 1 means we can say it as percentage, right? 0.6 if it is coming means 60 percentage this person has complete. Okay, course completion, like that you take course completion is there, and it is given in some different values, and I'm converting it from the range of 0 to 1. So I can say if it is showing 0.6 or 0.8 means 80 percentage that person has completed, 10 percentage he has completed. So whoever has completed less than 50 percentage, they are not eligible to go to next step. Okay, like that we can set some condition. Test case, okay, score, test score, like that also we can convert. Test score also we can say 0 to 100 will be there, that I can convert from 0 to 1. 1 means 100 marks, 0 means 0 marks. Okay, so if I say 0.75 means 75 percentage, like that also we can convert. Okay, then algorithm part is very important. So today we are going to see about KNN. So K nearest neighbor algorithm. Okay, so this is the K nearest neighbor algorithm will look like. Okay, so first we will see the definition of it. So by the name K nearest neighbor and seeing the diagram, can you able to come to any conclusion that what type of algorithm it will be? Some white dots is there in one point, and then orange dots is there, and I'm having one blue color dot in the center, and I have created one circle, and I'm saying K is equal to 3. So from this, can you able to uh, guess anything? Okay. Prakash is saying we'll be having on midpoint. Okay. Then which is closest to that. Uh, we are collecting closest to value k as 3. We are taking like that. You are saying. Okay, but not 100% correct. That blue point we can take it as new value. Okay, so new value I am placing. From that new value, nearest to some values I am taking. You are close to the answer only, Prakash, but that blue point we can take it as new value. That white and orange we take it as already existing value. Okay, so from that one new person job application has came, and that person I am plotting it in the graph. Okay, from that point, keeping it as that as center point, I am collecting few points near to that new point. So here I am giving k equal to 3. So 3 nearest to point I am taking. So from this, can you say this blue color point is there, right? Whether it will convert it into orange color or white color. Hmm. It will convert it into orange. Why it will convert it into orange? Because I have taken closest to point. From that closest to point, maximum points are in orange color. So obviously, that new point also will move to the orange point only. So we will declare as this new point belongs to the orange category. Two categories there, right? In our example, less than 50k. So these people, white and all people who are getting less than 50k, like that you assume. This orange color and all people who are getting more than 50k. On new point came, I'm taking nearest to 3 points, and from that maximum points are more than 50k. So I will declare the new point as this particular job applicant will get more than 50K salary. Okay, like that I will declare. Okay, we will see the definition. Any doubt? New value based on the age, salary and all we will feed to our algorithm. Okay, testing data is there, or we can, yesterday we created right if else condition and all we did. So similar way we will pass new values. Age value we will pass, salary, that hours, we will put it as input. Based on that input, it will say whether this person will get more or less. Okay, so first, okay, this. So KNN, so K nearest neighbor makes the prediction using the training data set directly. So directly in the sense whatever value you are passing it as a data set to our algorithm, it will try to plot all the values in the graph. Okay, then predictions are made for a new data point by searching to the entire training set for a K most nearest instant. So here instance means neighbor. Even if you are plotting 1,000 points, it will not check all the 1,000 points. Nearest K similar instance. Here I have given 3, so it is checking for 3. If I give 10 means 10 nearest point it will take, and from that it will check whether I will belong to category A or category B. Understood? Like that it will you know classify, and it will come to a summary summarizing the output variable for the K instance. Okay, this KNN algorithm very simple and effective algorithm, and it is also known as lazy learning algorithm. Okay, why we are calling it as lazy learning algorithm is until you request for a prediction, until you put a new value, it will not find a pattern or anything. Only if you are putting on new value and ask, okay, whether this particular point belong to category A or B. If more categories A means C, D, which category it belongs, if you are asking means, then only it will start searching for the nearest points, and it will check, okay, this belongs to category A, this belongs to category B. Okay, category A, this many points are there in this particular range. Category B, only less points are there, so the new point belongs to category A only. Like that, after we are asking for the prediction only, all this calculation will be performed. That is why we call the KNN algorithm as lazy learning algorithm. Okay, understood. Then this is for classification, it is okay. What if I use it for regression? We can use the KNN algorithm for both classification as well as regression also. Okay, when we come to regression, it is a continuous value, right? That time how it will predict is, here I have given, see, when KNN is used for regression problem, the prediction is based on the mean or median. Okay, nearest same example you take. Okay, in this example, assume that it is a regression type of problem. If it is a regression means what it will do is, it will 3 points is there, right? 3 points distance mean it will take, and that it will give it as a output. Okay, that will be the new points value, predicted value, we can say. Okay, for example, this orange is having value 12, this second orange is having 10, and this white color is having 5. So what it will do, 5 plus 10 plus 12 divided by 3, that is mean. Median means more value, 10 is there means it will arrange it in ascending order, and middle value it will take. It can use, either we can use it for mean or median method. Okay, that we can also specify some parameter will be there whether you want to perform by mean or median. By default it will be mean. Default value for that prediction is mean. Okay, if you want to change means you have to say type or some parameter will be there, exact parameter name I don't know. If you are changing means you can specify that also. No, that blue dot is not a mean value. Blue dot is a new data point plotted in our graph, and we need to return some value, right? For example, house price prediction is there. Okay, for house price, what are the information I will collect? I will collect square feet, how many bedrooms is there, how many bathrooms, so many information I'm collecting. Based on that, I have to give the price of the house, right? Either for rent or buying that house. So for that, what it will do is it will collect the nearest house prices. Okay, this house price, existing data, 1 lakh. This house price is 1.5 lakh. This house is only um, zero point 0.5 lakhs. Like that is there means it will add all three and divided by 3 because I'm taking three values. Then it will say, okay, this house price will be around 1.25 lakhs. Some assumption I'm saying. Like that, it will return the predicted output for us. Okay. So in today's data set, we are going to perform classification only, but regression means this is how it will work. Okay. Then we will see types. So this you understood, right? So it will work only when we are asking for prediction only. It will check what are the points are there, what are the nearest point, and which point belongs to which classification. So everything it will check and it will come to a conclusion. In case it is a regression means it will take for mean and median. Okay. Then when I go for the types, here we are having three, four types are there. In that most commonly used type is Minkowski distance metric. Okay, why we go for the Minkowski distance metric is in the Minkowski it is a summarized form. Okay, or we can say generalization of Euclidean distance and Manhattan distance. So I have already told about Euclidean distance and Manhattan distance. Do anyone remember? So when we go for Euclidean distance, when we go for Manhattan distance, so Euclidean distance means, can anyone remember when I told to when we will use Euclidean distance and when we use Manhattan distance? For direct distance, for direct distance we use Euclidean or Manhattan. For zigzag, Manhattan. Okay, just a minute. Okay. Yes. Okay. Some okay map is there like that you assume. Point A is there, person A or point A. Okay. From this point, I want to go to point B. Okay. So assume that it is a playground. Okay. Playground means no any what to say, blocks will be there. Okay, it will be like a empty land only. So what I can say, from point A to point B I want to go means I can easily say, okay, go like this. I can say, right? Whereas I'm not in the playground, or in the playground also in between one pond is there. Okay, around that pond some fins are there. So fins, right? We used to call fins only, right? That block. So there. So that time, can we say go like this? Is it possible? Whether the person can jump the fin, you know, swim in the pond, and he cannot go to the block B. So in that case, what you will say? You will ask him to go, person A to go straight. Okay, 100 meter you go straight, then take right, then again you go 100 meter means you can able to reach the point B. That is one you can say. Or from here you will say, okay, go in right hand side direction. Okay, again 100 meter you go, then take left, again 100 meter you go, and you will be reaching the point B. Like that we will be giving direction, right? Similarly in Google Map also, Okay, now I am taking the Google map. Google map is there. Again, point A is there. Okay. Nile Chennai is there. And then here, Gindi is there. Okay. Gindi bus stand is there. So I'm asking to the Google map. Currently, I'm in Nile Chennai. I want to go to the uh, some bus stand. Okay, nearby bus stand. I want to go. If the Google map is saying asking you to go like this, means is it possible to go? No, right? So in that case, how it will be showing? In between buildings will be there, roads will be there. Okay, some streets will be there. All are different, right? So mostly it will try to show you the correct path. Correct path in the sense main road. Only it will try to show. In case if you are going in some street, means what it will do? It will automatically recalculate the distance and it will show new distance, right? All these are possible because of that Manhattan distance type. Okay, so why this Manhattan distance got this name is there is one city, somewhere it is in Manhattan city is there. There all the buildings are built in the form of blocks only. Okay, proper blocks only they will be built that. Okay, otherwise I will show Manhattan blueprint. Okay, I will take this. So if you see it closely means everything will be like proper blocks. Okay, I'm not able to show it properly, so you can go and check it in the internet. Okay, see from the diagram itself some extent you can able to see, I think. See, everything will be in a proper blocked, it is a planned building. Okay, they develop planned, so it is easy to give direction like this. Okay, it will not be in an unstructured format, it will be in a proper structure format. Okay, see here you can see the street structure, building blocks, everything will be in some proper structure. That is why this distance got this particular name. Okay, so now you should have known where to use the Euclidean distance and where to use the Manhattan distance. Okay, here what we will use is we can directly use the Euclidean distance also, because we are not searching for real time distance. Here we need to uh, find the distance between one point to another point. Okay, so in our case, so for that we can use go for the Euclidean distance also. Okay, both the formulas I have given in the mind map itself. So this is the formula for Euclidean distance. So it is a calculation as the square root of sum of squared difference between the new point and then the existing point. Okay, it can be any point. So that is Euclidean distance. In case you want the distance to be in proper, okay, the distance between the real vector using the sum of their absolute distance if you want means, then you will go for the Manhattan distance. So in Manhattan distance, we will not be having any negative values. So that's why we are taking the absolute difference. Okay. This is also known as city block distance because there is one city called Manhattan. So that is why we are calling it as city block distance. Okay. And when it will be best, equilibrium distance will be good distance measure to use if the input variable are of similar in type. Okay, if the type of the different values are same, for example width, height and all is there means both will be in centimeter or meter, same measurement, right? So that time we can easily go for the equilibrium distance. In case the variables or the features are different scaling, Okay, age is there, gender is there, height is there, each are not same units, right? In that case, we can go for the Manhattan distance method. Understood? We are having another one method also that we will not mostly use. Okay, that method is known as Hamming distance method. Okay, so it is used for categorical variables. Okay, it will say yes or no kind of output. Okay, output will be like if d will be equal to 0, otherwise d will be 1. Okay, if it is having very large distance, in then it will say like 1. Large distance means 1. Very close distance means it will say 0. 0 1 binary values only it will have. It will not say how much distance is there, like that and all it will not say. Okay, that is why we will not use it mostly. Hamming distance. Yes. There by default positive only we will get. There if you are doing squaring means you will always get two values. Remember if you plus or minus one value will get, and obviously we are going to take the plus value only. But in Manhattan distance, there is a possibility of getting negative value. To avoid that only, we are going for absolute distance. Okay, that is the difference. There, two value we will get, and we will easily take positive value. But to avoid getting negative value in Manhattan distance, we are going for absolute difference. Okay. Here in Hamming distance also absolute distance I have mentioned. So value will be ranging from 0 or 1. It will not be 0 to 1, it is 0 or 1. Okay. Then what is the advantage of using this type of KNN algorithm? Okay. Minkowski, no, no, in Minkowski we are having only two distance only. We are having Euclidean distance and Manhattan distance. So if you want to use the Manhattan distance means there is one parameter called P. That value you have to pass it as 1. Then it will calculate in Manhattan distance. If you are giving value as 2 means it will calculate in Euclidean distance. Okay. Hamming distance is completely different. Okay. Just a minute. Okay. So advantage if you see means as I told it will be very easy to use. Okay, quick calculation time. Why? Because it will not consider all the plots. 100,000 data as I told if you are having in our data set also, it is not going to calculate all the distance, right? It is going to calculate only the k nearest distance. So obviously the calculation time also will be less if the k value is less. Okay, if I'm having more k value means obviously it is need to take lot of time to calculate the distance. And here it is not working based on the assumption. It is properly calculating each distance, then only it is predicting the value. So it is not, we cannot say it is assuming. It is like a rule. I'm checking nearest value. From the nearest, I'm having 10 class A, 10 9 class B means I have to choose 10 class A. So I have to convert to class A. That is how it will check. Okay, so when one algorithm is having advantage means obviously some disadvantage also will be there. That is why we are moving for different algorithms. Disadvantage if you see means distance of a new instance is computed with all the training samples every time. So every time in the sense here one blue dot is there, right? So what it will do, it will find the nearest three value. Again, another one blue dot is there. Okay, new value data is there, and near to that blue value only it is there. So instead of using the previously I know that what is the distance between these values, right? But what it our algorithm will do again, it will calculate the distance. because it is slightly moved from the one point to another point. Are you able to understand? See, what I am saying is, in my graph, one new point is coming. Okay, from that new point I am finding the closest distance. Okay, 5 points I am calculating, means again another one new point is coming near to that point, means again it has to start calculating the distance from this point. So this time what it will do, it will calculate 1 2 3 4, some other points also it will calculate. So each time it will calculate, right? That we are calling it as disadvantage. Okay, because it is not studying the data set, right? Each time it is newly studying, so obviously it needs to take some time, right? So that is considered as one disadvantage. Okay, then choosing the value of k is a toughest choice to make, as lower value of k result in highest influence of noise, whereas increase in the number of k might result in overfitting. Okay, so as I told, if I am taking only three nearest point, in this case, one white dot was there, so we can say all the classes it has checked. Correct. What if the blue dot came here, somewhere close to orange point? And if it is taking nearest 3 point, means all three are going to be what? Class A only. So that time it will not even know that class B exists. So that time it can be biased also, right? So that is one disadvantage. Another disadvantage is, what if some outlier values are there? Outlier in the sense, here in this diagram itself, if you see, means one dot is very far from that remaining white dots. You can able to see, right? Similarly, here orange also, one dot is very far from the remaining orange dots. So like that, one new point is also coming very far. That time it is very difficult to plot. I mean, find the nearest point will be very far distance, right? So calculation may be mismatch. So either we our data will be in overfitting, or it will be in underfitting. Okay, that is also some possibilities is there. Outlier, it is sensitive to outlier, new points. Okay, that is considered as another one disadvantage. Then another one disadvantage we can say is finding the exact k value. How we can decide this k value will be correct? For that we are having one solution, but generally we consider it as another one disadvantage. We have to perform some extra steps to find the best k value. Then only we can use that value, right? Otherwise simply we cannot give okay, n value, nearest value, take 5 value, take 10 value. How you will say this 10 or 15 or 20 is the correct value, best k value? We cannot say orally, right? We have to perform some testing. So for that we need to do some extra step, then extra time it will take to find the k value. Once found means we can use the k value, but for finding we are putting some extra time, right? So time consuming task only, right? So that we can call it as another one disadvantage. Okay, then KNN is computationally expensive, as it is searches the nearest neighbor for the new point at the prediction stage. Okay, previous algorithm and all, what it will do is, it will previously it will predict all the values. When new values coming means it will just give you the output. But in the case of KNN, after getting the new point only, it will start the prediction, start the learning process. That is why we are calling it as lazy learning, right? Understood what I am trying to say? In previous algorithm, all the pattern it will understand, algorithm will understand. Only when new value you are putting means, for the new value it has to say the output. Whereas in the case of KNN, after getting the new value only, it will start understanding the pattern, finding which category it belongs to. Then only it is starting lazy learning. So that is why it is called as expensive also, right? In the real time if you are doing means you want instant output. You cannot wait for the computation and all. So that is why they are calling it as expensive. Okay, so that is another one disadvantage. Yes. First advantage. Hmm. Yes, if you are giving the same new value again also as I told, it doesn't know, right? Already same value only user has given. That and all our algorithm doesn't know. Again it will, for algorithm it is something new. Okay, so it will start the process from the beginning. That is why they are saying it is an expensive task, right? Already that point has found means why I have to calculate again, but it will calculate because it doesn't know already point. It will not check. If it is checking means again it will be a time consuming task, right? One point I'm putting to my algorithm. If it is checking whether that particular point is present in my data set or not, again it has to iterate to 100 point is there means 100 points it has to check, right? Again it will be an another time consuming task. It is not there. If it is there also again time consuming only. It is not going to increase my efficiency, right? So we will not go for that part. Okay, then where and all we are using in the real time this KNN algorithm, where and all we are using is for movie and product recommendation system. Okay, in the Netflix and all, if you are seeing means, assume that two-person is there. One person watched one web series. Okay, another person also watched one web series. Same web series, two-person watched. Person A is watching new web series. Okay, I don't know, I didn't remember any web series name. You itself assume any web series name. Like Loki is there, right? Then Captain America something is there. So person A and person B has watched Loki web series, okay, and the person A is watching that Captain America one series was there, right? Winter Soldier. Person A is watching that web series means for person B it will come as recommendation. Okay, why? Because both has watched same series, right? So it will recommend like person is watched this particular web series has also watched this series. Even in YouTube also you will get the person who has subscribed to this particular channel has also watched this video from another channel. All these are what recommendation, making the new user to watch the videos. So this we can use it for KNN, nearest neighbor. Okay, same location because Chennai people like to watch Tamil series means we cannot recommend a Tamil series to North Indian. Okay, so like that nearest person which series or anything they product, same product also we can say. Okay, then text mining. Okay, we are using in NLP also. Okay, text mining means suggestion what the user is thinking to type. Okay, we will get some suggestion, right? When I give WE means it will say where, whether, like that some suggestion is getting, right? So that also based on the KNN we can use. Medical field we can use. Okay, COVID patients are there. Okay, and one particular area whether the new person will get COVID or not, like that some prediction we can make. Okay, medicine we can recommend medicine for this particular category of symptoms, this disease was there. Okay, so whether this particular person is having cancer or not, lung disease, heart attack, like that we can predict in the medicine part. Then stock prediction, whether the stock price will increase or decrease, like that we can say. Then climate forecasting, right? Based on the nearest location, temperature, humidity, whether rain will come to my location or not, that also we can predict. Okay, these are all real time some example of this KNN algorithm. Okay, I'm not saying only this algorithm they are using, but this algorithm also they can use for uh, recommendation system, medical field, prediction, stock price prediction, climate forecasting, those real-time application they can use. Okay, up to here clear for all. Okay, Thank you. Yes, yes. All category we can perform both regression and classification in KNN, right? That is what I mean. So climate, what they will do, nearest climate temperature it will take, and it will mean value of, okay, because uh, surrounded me some temperatures high means obviously I am also going to have a high temperature only. For me, I'm not going to get any rain. Stock prediction also, some closest to product, one particular a company product is getting high means obviously a close product also will be high. That is what I meant. Okay, so complete picture of KNN algorithm we have seen, and remaining steps and all common only. Like we will be here we will be finding the k best k value. That is one new step in KNN. What three new steps we have seen? We have seen mapping. We have to map the categorical data into numerical data, and we have to perform algorithm. Then we have to find the k best k value we have to find. Okay, so for choosing the k best value, what we will do is we will be plotting for each k value. I will start from k is equal to 1 and some range I will give. Okay, from here what I have done is I have given some range starting from 1 to 40. I am plotting the k equal to 1 means, okay, nearest neighbor. One neighbor if I take means, and I am finding the mean error. Okay, from the figure you can able to observe that, see, when I am taking only one k value, k nearest neighbor, my mean error is very high. When I am taking 2, it is reducing. 3, still it is high. So like that it is slowly start reducing. So from 15, okay, after 15 if you see means it is very less value. Error is very less, okay, when compared to other. And if I ask you in which point my k error is very less, which point you will choose from this graph? Can I say 16? I'm 16 if I take means it is the I can say 16 or 32, 30, 31, 32. I can say those are having very less error. So I can, instead of checking one by one, I can check one or two values from the k. Sometimes we will be having very less error for 2 3 values also. So we will check with 3 values or 2 values, and from that we will check the accuracy. If accuracy is more for any one value means we will fix that value as best k value. In this case I can go for 16. Okay, because uh, 16 is having very less error when compared to remaining. Okay, it so how you may ask, sir, how I will decide I have to take from 1 to 40? What if I have taken 1 to 20 only? Or 1 to 10 if I taken means what will happen? It is like trial and error method only. First you will be taking from 1 to 10 or 1 to 20, and you are seeing which is having very less error. So then 20 to 30 you will increase, 30 to 40 like that increase. So if you see the pattern, 20 to 30 means it is having like same minute difference only is there in the error. Similarly from 30 to 40 if you see means again error is very less only. Okay, not very big difference you can able to see. In 16 itself we got the less error. So we can stop with up to 20 also if you want. Okay, but initially we don't know, right? What will be the k best value. So it is good to give large range. Then we can slowly reduce the range and we can fix. Okay, 1 to 10 if I give means 1 to, in this case you have to give 1 to 20. So 1 to 20 I compared, in that I am getting a best score in 16. Like that we can come to a conclusion. Okay, that we will put it in the formula. Mean square error we found, right? For linear regression, mean underscore square underscore error, in that we will put, and we will store all the error in a list. Okay, then we will plot that values in our graph. Then you will be getting that. Okay, that we will see in the coding part, we will see. Then we have to train our model. Okay, by model field we will give. Then we have to validate our model. Here one mistake Nishant has done today. What mistake is, he tried to perform confusion matrix and accuracy score for regression type of problem. For regression you have to use mean square error or root mean square error you have to use, and then R2 score for finding the accuracy. If it is a classification type of problem only, then you have to use confusion matrix and what accuracy score you have to use. Always remember, right? Regression means root mean square error R2 score. Classification means confusion matrix accuracy score. Okay, we cannot interchangeably use that. If you are going and using the confusion matrix in regression means you will be getting error. Okay, value error, multi-class error you will be getting. Okay, initially you may not know that, right? So that time you will think why it is getting error like that. You will think this is will be the reason for that. Okay, then finally we will be predicting. Okay, based on the testing data we will predict and then validate, or we can pass in new data also into the program and we can predict. Okay, so shall we see the program part? Okay, for explaining the algorithm itself, 1 hour gone. Okay, we will see the program part a little bit faster. My Jupyter notebook is visible, right? Okay, just a minute, I will close everything. Okay, so basic steps and all I will go a little bit fast. So import. Okay, so import pandas as PD. Then dataset is equal to like. So here my file name is salary.csv. I have already showed it to you. So I'm using that name. Okay. Then I'm going to summarize. Okay, some 10 values and take. So totally see, I am having 32,561 rows is there. Okay, and 5 columns is there. So from that I have taken some sample data. Okay, 10 data I have taken. Then now as we have seen in the fourth step, we have to map the salary data to binary value. Okay, so for that, so if I want means I can update in the original data itself. Okay, so data set. So in that I am going to take the income part. Income is equal to data set of income. Okay, that particular column value I am taking dot map. Okay, so map function I'm going to use similar like replace method only. So I have to give it in the dictionary format. Okay, so which data I want to change, less than or equal to 50k. K should be caps, same what we have given in the category that we have to give here also. That converted into 0 comma, then in the codes 50 greater than 50k converted into 1. Okay, so to make it, keep it as integer. Okay, 10 is integer only, right? So by default it may be taken as float possibility is there. So to avoid taking it as float, what I can do, I can give another one method also as type integer int. I have to give it as int. So now first it will convert the numbers to 0 and 1, and 0 and 1 will be in the format of integer. Okay, that is the only thing. So now let me go and check my data set. So dataset.add. See, values has been converted. So I will give 10. If I rerun this, okay, what mistake people used to do in this program is I have already converted, right? Now I have converted and I have updated in my original data set itself. Uh, what they will do is instead of giving, I have given head here, right? They will give 10. Okay, just to see more rows, and they will run means sometimes it will throw error. What error will do is the value you are trying to convert is not present in the data set. It is not present in the data set because I have converted it already, right? I have converted and updated. So that mistake you should avoid. Okay, once you have run and updated the actual data set means we cannot run the same thing again. So that's why I'm putting it separately here. If you want to run means again you have to import the data set, then only it is possible. Understood what I am trying to say? Previously it was underscore I mean less than or equal to 50k. Okay, I have converted into 0 and 1. Okay, now again if I try to convert means like this it will throw error because already the data has been converted, right? So in case if you are seeing this error means understood that you have already converted the value. Okay, that is why you are getting this error. Okay, no, I have converted and updated in the original data set. For 10 it is not throwing error, Prakash. For conversion, for mapping, it is throwing error. Okay, for 10 it is not. I told in the same cell head also I have given, right? That time I will get error. That is what I meant. So to if you want to avoid that error means again you have to import the data set. Again you have to perform this step. Then you have to run this step again. Okay, then now it will be 0 to 1. Okay, then I'm going to segregate the data into x and y. So capital X, so dataset dot ilog colon comma. So this and all should be like mug up. Even we used to say, right, even in sleep if we wake you up and ask the syntax also you should able to say like that. You should memorize all these things. Okay, this is my x value. Okay, so many columns, I mean, so many rows are there, right? So that's why it is showing like dot dot dot. Okay, don't think like only it is showing to only six values. Okay, similarly for capital Y, dataset dot ilog colon comma -1 dot values. Okay, then okay. So one more thing also is there. In previous class also I have missed to say. What we can do is uh, feature selection, one option also is there, one step also we can do. What this feature selection will do is we are having five columns, right? Whether the five columns I need or not for training my model, that we can check it by using this feature selection method. Okay, in previous uh, logistic regression also you might have done, but there we had only two or three columns only, right? Only two columns we had. What are they? We had age and salary. So that's why I didn't use there. Two column also, two is important only. In case if you are having 10 column, 20 column, that time all column may not be needed. That time this feature selection step will be useful for you. Okay, I'm showing you the syntax and I will show you, but I will not be using for all the algorithms. I'm just showing the syntax. That is known as feature selection. Which are all the columns I need it for training my model. That also we when I test means you will know whether we need or not. As we have previously done, it is saying true only. I will just show you. So features selection. So for performing feature selection from sklearn dot feature selection one. See, feature extraction, feature selection is there. We have to choose feature selection. So from that we have to import one method called RFE. Okay. So this is like recursive feature extraction. Okay. For each column it will check whether this is useful, whether this is useful, like that it will check. Okay. And the algorithm which I am going to use, that I will extract from sklearn.c. For linear regression, I have imported it from the class called linear underscore model. Right. For KNN, we have to import it from dot neighbors. Dot neighbors. From that, we have to import k neighbors classifier. So k nei k and n caps. Okay. Nei gh k neighbor classifier. Okay, this algorithm I am going to use. So what I will do is I will create a model for this particular uh, class. Okay, I'm creating one object and I'm RFE is equal to RFE, the function. I will pass the model, comma, and then I will specify the feature. How many feature I want to extract. So I have to specify it as n feature to select is equal to n underscore features underscore to underscore select. Okay, you should give it like this only. You can give any number. Okay, it is not that you have to give how many columns is there, that many numbers only you have to give, not like that. I'm asking how many features I want, like that I will give. Then, okay, in the RFE itself, I will update the value. So RFE dot fit x and y value. See, this feature selection is optional only. Okay, even if you are not doing also, I can proceed with the next step. Just to know you what to do, I am showing it to you. So after performing the fit, we can check the value by using the dot support support underscore. Okay, see RFE dot support underscore, and another one is there, that is RFE dot ranking. So if I run this means, if I use only support means, it will say true, 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 true. So four columns important to me. If it is not important means it will say false. If you are using ranking means you will get rank in the format of 1 or 0. 1 means you can use that particular column. 0 means you don't need to use that particular column. So in our case, we need that capital, what is that column name? Capital, capital gain also we need. 4. Why I am getting 4 true? Because age, education number, capital gain, and then hours per week. 4 columns is here, and 4 I got true. So I am going to use 4 columns. Okay. If anyone comes false means we can delete that particular column also. Here that this particular function is there, right? This function, what we will do is, for this particular model, see I have passed the model. In that model, n feature select is there, right? I've given n number of features. So each column it will pass into the model and it will try to fit it, and it will test the model. After testing, it is saying whether it is useful for our algorithm or not. If it is not useful means it will say false. I don't need this type of values. Mostly where you will get, where we can get the data sheet. Data sheet means what? I will share the data set with you. Okay.
and then ranking. Okay, any one is enough. If you are putting support means you will get as true, 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 true. I mean true, false. If you are putting as ranking means 1 or 0 it will return. Based on what category means what criteria it is taking. That's what it will try to perform some validation. Inside that, some inbuilt code will be written for validating the each column. Okay, it may be testing whether it is a numerical column or not. It may be testing. Okay, whether that value is affecting our model or not. Okay, like that it will do multiple testing. If the test condition become false, okay, it is affecting our data set. Because of this column, my data are not my prediction are not accurate. In that case, it will ask you to remove that particular column. End of the day, uh, those column will get less weightage only. Okay, even if you are not performing the feature selection. Okay, you skipped this step. In logical regression, I skipped this step and directly went to the next part because I'm having less column. Even if I'm having more column also, if I skipped means whichever columns are important, our algorithm will give more weightage. Not important means it will give less weightage. Okay, then I have to split the data set into train and test. Okay, so this again you all know, so I'm just typing the code. Learn dot model. Okay, splitting part over. Then I have to do feature scaling also. Just a minute, please stay in the line. So standard scaling method only I'm using. So same steps only. So I will just type fast. So we have to use fit transform for train and transform for testing purpose. It is not a standard rule, but we used to follow this procedure. Okay. So next step is finding the best k value, right? So right now I'm not going to find the best k value. So first we will see how to, you know, uh, use the model training and remaining things we will see. Then we will find the best k value. Okay. Initially you don't know, right, what will be the exact k value. So randomly I'm giving one k value and I will find the accuracy. Then I will find the best k value and I will check whether I'm getting any good accuracy or not. Okay, so from sklearn dot as I told already I have imported, so no need to import it here. Okay, for features selection itself I have imported the algorithm. So if you want means
for remembering purpose, I will put it here also. Okay. Otherwise, no need to import again and again. Or if you have seen different code means all the importing statement they will put it in the initial stage itself. That also you can do if you know what algorithm you are going to use, what operations you are going to perform. Okay. Now as I know I can put it in the same, but you may not remember, right, why I'm putting this thing. So at that particular point if I'm putting means okay, in this stage only we need to import this, we are using this, that you can able to relate it. Okay, so model same k nearest neighbor classifier. Here I have to specify how many neighbors I want to give. See here I didn't specify anything in the feature selection. So what will happen is it will take the default values for all the neighbor. So default value will be 3 only. Okay, nearest neighbor. Like that some default settings is there. So based on the default settings only, I have performed the feature selection. But in this case, I'm going to specify how many nearest neighbor I want to take. Okay, so nearest neighbor is equal to what we can give. I'm giving 10 or I'm giving 5. Okay, 5 nearest neighbor you take. Okay, from the new point. And metric, you have to give it as metric. I told right, we have to specify Minkowski. Okay, we are having Minkowski, or in the Minkowski only we are having Euclidean and Manhattan distance. Otherwise, you can instead of specifying it as Minkowski, you can specify as Hamming distance also. Okay, so Minkowski. So if you are specifying Minkowski means we have to specify the p value also. So p is equal to 2 I am going to give, which is Euclidean distance I am going to give. Okay, so based on that train my model. Okay, so training completed. Now okay, so before going to the prediction also, what I will predict with the testing values. Okay, so y predict, just a minute, sorry, y predict is equal to, so model dot predict and then the x test value. Okay, because testing value I'm passing to my model and it will return me the y predicted value. Okay, so I can even show you the predicted values also. So this is how it is predicted. Okay, now I have to evaluate my model. Okay, still I haven't found the best k value, so my output may be vary. Okay, so from sklearn dot metrics input confusion matrix and then accuracy score. Okay, so CM, so confusion matrix, y test, y predict. So this syntax and all I have already showed to you, so that's why I'm typing a little faster without explaining anything. Directly also you can put it in the print statement, right? That you also know. So into 100. Okay. So shall we check how much percentage we are getting for k value is equal to n. So See, for giving 5 itself, we are getting 80% accuracy, 80.5% accuracy we are getting. So let us find the best K value. Okay, and we will check whether we are getting even more better accuracy or not. Okay, here, near neighbor value I have given, right? See, n neighbors is equal to 5. So which means 5 nearest neighbor value you collect. Like, that is the meaning for this. No, this is the value. K value means nearest neighbor means 5 is the K value. New value means blue color. We haven't passed any new value yet. We have only tested the data. See, that new value is nothing but the testing data. Okay, it is predicted based on the testing data, X values. All are new values only. Based on that, it is given one new output. We compared that and we found that 80% of data are matching. Okay, with the original value. Now, I am going to find the best K value. Okay, so for finding the best K value, so I will create one um, list, error list. So all the error values will be stored in this particular list. Okay, so here also, just for understanding purpose, here also I'm using the algorithm. Okay, so I'm just importing, and then for plotting I need to put matplotlib, right? So what I'm going to do is, so I'm going to calculate the error for K values between 1 to 40. So that is what we have seen in the mind map also, right? So 1 to 40 I'm going to take. So for this simple for loop only, basic thing only I'm going to do. For I in range, okay, 1 to 40 I will give. 1 to 45 give means 1 to 39 it will take. If you want means you can give 41 also. So I will give only 1 to 40. Okay. So inside that I have to give model is equal to same thing. Whatever I have given for the prediction. Model K is equal to everything I have given, right? Here simply I will give model is equal to, so K nearest classifier. So n neighbor, what I will do? I will pass I value. Okay, so each iteration my nearest neighbor value is going to change from 1 to 39. Then based on that n value, I will train my model by giving model.fit x train and y train. Then immediately I will start predicting also. So I will, based on that I will predict the model. So model dot predict the x test value. Okay. So here how I will find the error is, so error dot append np dot mean. Okay, I will try to find the mean of error, how much error I am getting between predicted I value. Okay, it when it is not equal to the testing value. Understood what I am doing? 10 test values there. Okay, 10 predicted values there, 10 actual values there. If uh, 5 values are not matching means 5 by the total value I will take. That I will put it as mean error. That is the mean, right? Out of 10, 5 is not matching means 5 by 10 like that I will put, I will take some mean value. That I will store it in the error list. Okay, finally I will print and show you the error also if I want. Okay, finally simply for our understanding I will print the error list also.
Okay, then I have to plot the graph, right? So here in the plotting, we are having one method called figure. So using this figure, what we can do is we can set the width and height of our graph. Okay. So for that, what we need to do is we have to give the figure size. So figure size like 12 6. I'm just giving some value. Okay. Width and height I'm giving. Then I'm going to plot. So for plotting x, what I will take is I will take the range 1 to 40. So what range you have taken here, same range only you have to take here also. Okay, otherwise value will be more, plotting will be less, then it will throw you error. Okay, then for y value, I will take the error list. Okay, so color I can give it as red. Okay, then line style I will give it as dashed. So this and all we can give it in single thing also. So marker is equal to O. O means that 00 dot, I mean points will be coming, right? So like that I can give. To get the same graph like the mind map, we can also give a marker face color is there, marker size is there. By default, the marker size will be very small, right? We can increase the size also. So for that, what I can give is marker face color means in the circle outline we can say we can give different color also. Okay, so face color if I give means COLOR and I can give it as blue. And then marker size I'm just increasing the size to 10. Okay, then uh, basic thing we can I can give title. So in the title what I can give so error rate for k values, and then for x label what I have to give, x labels are nothing but the k values, right? Ranging from 1 to 39, and y labels are going to be my mean error. So let me run. It will take some time because 40 times it has to do, right? From 1 to 40 means 39 times it has to perform the operation. So obviously it will take some time to complete this particular process. Okay. Okay, I think it is completed. Okay, I'm getting some error. Okay, that day also when I was executing attribute error range 1 to 40 error color everything I have imported attribute error line 2D object has no attribute mark. Okay, sorry, spelling mistake. Marker, not mark, marker face color. Marker face color. Okay. Okay. See, same graph which you have seen in the mind map, I have created. The blue color came for the dot, like that it came, and the red color become outline for this. And I have used the dashed line, that is why line is showing like this. Okay. So here, if you see, means in 15 I am not getting. Okay, that is different diagram. Okay, different data set. Here in the 30 only I am getting the very least error. Correct. I'm not getting for you know 30, 31, 30, 30, 30. 30 only I'm getting the least error when comparing to other error values. So what I will do is in the place of 5, I will convert to 30 and then I will check, okay, whether I'm getting some better output or not. So I've converted it into 30. So let me predict the value. So let me again check whether it is increased or not. So previously I was having 80 percentage, right? So now I got 81.7 percentage. So likewise, we can find the best match for our k value. 5 means somewhere it is matching. We can test it with any other least value also. Uh, Next to this, any least value is there. 20, 22 also same. I think 30. 1, 2, 33 also we can say so, like that. We can test it with through three values. You just experiment on it, and whether you check you are getting any even more accuracy for the data set which we are having. Okay, and finally we can predict with the new age and hour of worked. Okay, we don't need to give all the values. We can simply give age and hours he has worked. Okay, okay, then we can find whether the person will get salary more than 50K or less than 50K. We can check for 4 column also, or we can give the main 2 column also. Okay, both will work. Ah, yes, minimum in error 30 only. A, accuracy may increase or decrease. May increase. Why? Because we are testing the K value with training data only, right? How our algorithm got trained, we don't know. So that is why I told it may maximum possibility is very less only because we are testing it with the testing data only, right? So very less, whichever from our graph 30 is having the very less error, so we can go with the 30 only. So maximum accuracy that I've asked you to experiment is what type of accuracy you are getting to experiment. I told maybe 81 may be the highest accuracy in our case. Okay, so let us see how accurately it is finding the new value. Completely new value I'm passing. Okay, we don't know what is the actual output for this also. Okay, so enter new employees age and then working hours. I'm just giving it as uh, work underscore hours. So enter new employee hours per week. Okay. So what I have done in the previous class, like new student I have given, I think. So here new employee. Okay, there also new employee only I have given, I think. So age, comma, work hours. Okay, then I will store the result. Model dot predict. Okay, and I have to convert sc dot transform the new employee detail. Then for our understanding, I am printing the result. Okay, what result our algorithm is giving. So obviously it is going to give 1 or 2 0 only. So if the result is equal to 1 means employee might got salary above 50K, else employee might not got salary above 50K. Okay, So shall we check with some example? I'm giving 41. Okay, so age of a employee is 41 and every week he is working like 60 hours. 60, okay, 61 hours he is working means whether he will be getting more than 50K or not. I'm asking to my algorithm. Okay, spelling, any spelling mistake? Okay, TRAN, yes. Okay, I was typing in a little bit fast, that's why I got. So same I'm giving. So 41 is age, 61 is okay. Again, I'm getting error. What error? X has two feature but standard. Okay, okay. I have to give all the features. That is the mistake I have done. Okay, so can you give the remaining features and test it by yourself? Remaining feature means you have to give the education and then the college grade or something is there, right? Education number and capital gain. So okay, that also I will give it and show it to you. So if you are giving means, so int of input of, okay. Easy system, no? Easy system. மறுபடியும் என்ன பண்ணலாம்? Okay, so enter new employees education. Education means it should be in that number format. Okay, actually with two values it should come maybe during the time of training. We should give only two values. Maybe that time you will be using only age and weeks used per sorry, weeks worked per year week. Otherwise we have to give all the four values. Okay, so no problem in giving all four values. So hours worked, then college sorry, not college capital gain, that also int of. So enter new employees capital gain. So then I have to update this also. So age, and then I'm going to give the education, and then work, sorry, capital gain, and then the work hours. Okay. So then I will pass the new data set and I will find the result. So let me check this. So age, um, okay, 40 I'm giving. Education I'm giving 20. Okay. New employees hours work done 40 hours. New capital gain 0. Okay. So our algorithm is predicting that the employee might got salary above 50K. Okay, like that it has been predicted. Okay, we are changing the values for each age education means it will be giving some other value also means the employee might not be getting a salary greater than 50K also you will get it as output at some point of time. Okay, understood this algorithm and this entire coding part. Practice the code. I will not share the code. You just practice with the video. Okay, and I will share the data set. The salary.csv file, I will share it with you for sure. Okay, any doubts is there? Okay, I have taken a lot of your time, I think. So hereafter, maybe 1 hour may not be enough for me also. Sometimes it will take 1.5 hours also. So I expect you have some patience
and follow along with me. Okay, thank you all. See you in tomorrow class with a new algorithm and new data set.